All right, today we're switching it up a bit. Our objective will be to use permutations and combinations. So this is lesson 6-7, permutations and combinations. All right, permutations and combinations use the idea of factorials. Does anybody remember the symbol for a factorial? No. Factorials, they're so exciting that we use an exclamation point for them. The symbol for a factorial is an exclamation point. They are just that exciting. I shouldn't have put that up there yet because now I gotta, there we go. Do we remember what a factorial means? 3 exclamation point. 3 factorial means we start with 3 and we multiply all of the integers down to 1. So in this case it would be 3 times 2 times 1.
I don't remember.
You guys didn't learn this?
No.
Huh.
Freshman?
I guess it would have been in Algebra 1. No? Okay, well, factorials aren't that hard. You're just multiplying numbers, starting with whatever number they tell you, all the way down to 1. So 3 times 2 times 1 would equal 6. Okay, now 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. There is a calculator button available. Okay, so for most people, it's probably under the PRB button on those blue TI calculators. So if you type in whatever number, so type in 7, and then press the PRB button, you should be able to scroll over to the exclamation point and press enter, and then press enter again.
PRB, and then
Okay.
go to the exclamation.
And then go to the exclamation point.
And enter.
Yep, enter again. Well, you'd have to type in 7 first.
So you're supposed to hear 50/40?
Yep. Now, you don't need to be able to use that shortcut because you can take 7 times 6 times 5 times 4 times 3 times 2 times 1. All we're doing is multiplying. So you could do that by hand or in your calculator. But if you would like to use that factorial button, it is there. All right, permutations. A permutation is an arrangement of items in a particular order. Factorial notation can be used with permutations. So for our first example, in how many ways can 10 dogs be lined up to be groomed, or line up to be groomed?
10 ways.
There are more than 10 ways. So the way that I was taught to think about this is think about, the way that I was taught to do this is to think about how many options you have for every place in the line. So when you first start the line, how many options do you have? How many dogs do you have to pick from? 10. When you go to the next place, how many dogs are left to choose from?
9.
The next place.
8.
After that.
7.
And then?
6.
And then?
5.
Next.
4.
How many options now?
3.
Then?
2.
And that would be equal to what factorial?
3,628,800.
Not the number, the factorial.
Oh, 10 or 10 exclamation point.
Okay, that's equal to 10 factorial. So if all you're doing is arranging in an order, you have 10 to choose from, they've got to be lined up, then it would be 10 factorial. And yes, you could use your calculator to actually get that. And what was it, Jacob?
36. Oh, I meant 3,628,800.
Do we agree with that?
Mm-hmm.
Okay. So then how many ways do you think you can arrange 6 trophies on a shelf?
6 times 5 times 4.
What would be the shorter way of saying that?
Oh, 6 factorial.
6 factorial. So you should get 720 for that. If there are 20 students in this classroom, how many different ways could they line up to exit the room? What's the short way of writing this? 20 factorial.
Oh, man, that's
Go to the scientific notation.
So what does your calculator tell you?
2.4.
Yeah, it's 2.4.
2.4 what?
2.4329020008 times 10 to the 18th power.
Yeah, that's what mine.
Times 10 to what power?
18.
Times 10 to the 18th. That is a really, really, really large number. Okay. If your calculator won't give it to you on something that large, I would accept 20 factorial as an answer. Okay. On the other ones, I would want you to either multiply it out or put it into your calculator. So when we use a number of permutations of n items in a set arranged r items at a time. So we have n items available to us, but we're only picking or using r of those items. So the notation for that is the n, little n, capital P, little r. And to calculate it, we take n factorial divided by n minus r factorial. So we have n items available. We're only using r of them at a time. Okay, so if we have 16 and we're arranging or picking 10 of them, 16 factorial over 16 minus 10 factorial, we simplify the 16 minus 10 to get 6. Now, when we write this out, this is going to be able to be simplified so that we don't have to do all of it in the calculator. If I start writing out 16 factorial, 16, 15, 14, 13, 12, 10, 9.
You forgot 11.
Oh, all right, we'll go back and add 11. I got excited. I wanted to get down to 6 because I'm going to leave the 6 as a factorial. Why do you think I might want to leave the 6 as a factorial?
So that's how many students are left.
What's in my denominator?
6.
Not just 6. 6
Oh.
factorial. Let me add in my times 11 there. Okay, so if I have a 6 factorial in my numerator and in my denominator, what do you think happens to those? They can simplify how? If you have the same thing in the top and the bottom. They cancel out. So 6 factorial cancels out with 6 factorial. Now, in this particular problem, you're still going to get a rather large number because now what do you have to multiply together? You've still got to multiply all these numbers in the numerator together. Or there's a button on your calculator that'll do this all for you. If you don't want to have to simplify and multiply it out, in your calculator you could type 16, go to that PRB button, select the NPR option, should most of the time is the first option, and then type a 10. This one will still give you a really large number, right? What do we get? let's just round it to like 2.9 times 10 to the 13th. Are you sure? To the 10th.
Oh, yeah.
Okay, so it would be approximately 2.9 times 10 to the 10th. Okay, so you can either expand it out, or you can use that button on your calculator. Let's do another one. Ooh. This time, let's do 12. And we're going to pick 3 of them. So again, either, well, let's first plug it into our formula. What's going in my numerator? Not just a 12. 12 factorial. What goes in my denominator? 12 minus 3 factorial. Okay, 12 minus 3 is 9, so that's 9 factorial. So if we expand this one out, it's not going to be as bad. So 12 times 11 times 10 times 9 factorial. Okay, I just go down to 9 factorial because my goal was to do what? Cancel it out with my denominator. So then I'm just left with 12 times 11 times 10, or from the very beginning, you could have typed it into your calculator. 12 NPR 3 equals. Either way, what do we get? A little slower?
1,320.
Beautiful. Do we have questions about the expansion part? Okay, now this is probably going to be easiest if you have a scientific calculator that can help you out, but I want you to know you don't have to have a calculator if you're able to expand it and cancel it out. Now, before we actually do number 6, do we have any guesses about what the answer might be?
0.
Interesting guess, that's wrong. Any other guesses? Did you already calculate it? Yeah?
1.
Okay, so if we were to set it up in our numerator, what would we have? 5 factorial. In the denominator? 5 minus 0 factorial. What's 5 minus 0?
5.
What happens here? They cancel each other out, so we're left with 1 over 1, which is just 1. So what we're doing here, what we're saying is we have 5 options. How many ways can we pick none of them?
1.
There's only one way to pick nothing. Okay? All right, are we ready to move on? The next problems are not a whole lot different. We just have to decide how many options we have and how many we're picking so that we can set it up. 7 yachts enter a race. First, second, and third places will be given to the 3 fastest yachts. How many arrangements of first, second, and third places are possible with 7 yachts? How many options do I have total? So how many objects are we using?
3.
Nope. 7. Why 7?
Oh, 7 not.
There are 7 yachts. So there are 7 possibilities. And how many are we picking? 3 of them. So again, you can use your calculator or we can set it up with the formula. 7 factorial over 7 minus 3 factorial. So 7 minus 3 is 4 factorial. So we'd have 7 times 6 times 5 times 4 factorial. We can cancel out the 4 factorials. And if we take 7 times 6 times 5, what do we get?
210.
210. Again, from the very beginning, if you were to plug this into your calculator, that is allowed. So there are 210 possible arrangements of first, second, and third places. Out of 20 students, a president, vice president, secretary, and treasurer are chosen. How many arrangements are possible? So how many items or objects do we have to choose from? 20 total to choose from. How many of them are we choosing?
4.
How'd you come up with 4?
President and vice president, secretary, and treasurer.
Good. 4 different offices. 1, 2, 3, 4 offices to choose from. So you can either use your calculator or I'll show setting it up with the formula. 20 factorial over 20 minus 4 factorial. 20 minus 4 is 16. So we would have 20 times 19 times 18 times 17. The 16 factorials would cancel each other out. Who came up with an answer for this one? Devin? 116,280. Do we agree?
C.
Wonderful. Friendly reminder. In a permutation, order does matter. Order does matter on these. We're about to talk about another type of arrangement where order does not matter. It's a wonderful guess. Yes, we are about to start talking about combinations. Order does matter in a permutations. For a combination, a selection in which order does not matter is called a combination. A selection in which order does not matter is called a combination. Okay, so we have another formula for that. It is very similar to that of a permutation. For a combination, we again have n items to pick from, and we're only choosing r at a time. We have n factorial divided by r factorial times n minus r factorial. So yes, this one is NCR, C standing for combination. Again, you have a nice option in your calculator for this. All right, so it was suggested to try 2 and 6. However, we have to be careful about what order we do this in. If I only have 2 items to choose from, can I choose 6 items? No, not a thing. So we would have to do 6 items, choose 2 of them. That would be something we could do. Okay, you cannot pick more items than you have to pick from. So if we're setting up the formula in our numerator, what would we have?
2. Oh. 6.
Still n, so 6 factorial over. In our denominator now, we've got more stuff. We have r factorial, so this time that would be 2 factorial times 6 minus 2 factorial. What is 6 minus 2? Good. So we have 6 factorial over 2 factorial times 4 factorial. Okay. So I am again going to break down the 6 factorial in order to get to the 4 factorial because that's my bigger one in the denominator, and I want to cancel that out. So 4 factorials are going to cancel out. What is 6 times 5? 30. 2 factorial is just 2 times what? 1. 2 times 1 is 2. What's 30 divided by 2? 15. Again, your calculator has a nice NCR option that you can use. You should have gotten the same answer. Yes.
So the N will always be bigger than R.
Yes, your N has to be bigger than the R. Okay, let's try another one. Anybody else have a example they want to try? 10 and 5, sure. Devin's got all the examples.
I have a question.
All right. If we're setting this up using the formula, what goes in my numerator? 10 factorial in my denominator.
5 factorial parentheses 10 close parentheses factorial.
Beautiful. All right, what is 10 minus 5?
5.
So we have 10 factorial over 5 factorial times 5 factorial. I start expanding my numerator. 10, 9, 8, 7, 6, and then 5 factorial. So in my denominator, I can cancel out one of the 5 factorials. If you're doing this by expansion, the other 5 factorial can start getting expanded. So 10, 9, 8, 7, 6 is what I have in the numerator. In the denominator, I would have 5, 4, 3, 2, 1. You don't have to put the 1. Okay, but I noticed that 5 times 2 would give me what? 10. So if I can cancel the 5 times 2 with the 10. Okay. What else can cross reduce?
8.
8 could cross reduce with the
4.
4. The 8 becomes a
2.
2. What else can cross reduce?
3.
9 and 3. The 9 becomes
3.
a 3. So now in my denominator, what's left? In the denominator. There's got to be something. A 1. Okay, we can't divide by 0. We'd have a 1 left in the denominator. And then in my numerator, I'm just taking, what, 3 times, times, good. So that would all be over 1, technically. You don't have to write the over 1. And did anybody multiply those out?
252.
252 would be our answer. Next example. A DJ wants to select 5 songs from a CD that contains 12 songs. This example is getting rather dated, I feel, but that's fine. How many 5-song selections are possible? So how many options do we have? 12, and how many are we choosing?
5.
Okay, so if you want to use your calculator, that's fine. Otherwise, we can set it up with the formula. In the numerator, we would have
12 factorial.
12 factorial. In the denominator, we've got
5 factorial parentheses 12 minus 5 close parentheses factorial.
wonderful. So we have r factorial times n minus r factorial. It's that same formula from that box above. What is 12 minus 5?
7.
Okay, so we have 5 factorial and 7 factorial. I start expanding 12. 12, 11, 10, 9, 8. I take it down to 7 factorial so that I can get rid of my bigger factorial in the denominator. Those are going to cancel out. Okay, the 5 still has a factorial on it, so let's not cross it off just yet. Let's expand it. So we've got 12, 11, 10, 9, 8 in the numerator. In the denominator, we've got 5, 4, 3, 2. You can put the 1 if you want to. That makes you feel better. All right, what can we cancel out?
The 10 and the 5 and the 2.
Okay, 5 times 2 is 10, so those can cancel.
The 9 and the 3 and the 9 times the 3.
So we can cross reduce, but what does 4 times 12, or gave it away, 4 times 3 equals 12. So I think it's easier if we just totally cross cancel 4 times 3 with the 12. If you do it other ways, it's fine. You're just going to have more numbers to multiply together. Okay, so we can totally get rid of the 10 using up the 5 and the 2. We can get rid of the 12 by using up the 4 and the 3. And then we're just left with 11 times 9 times 8. What is it? 864. Wonderful.
How do you put this in the calculator?
So why are those crossed out again? Is that what-
792. Okay, so if we haven't gotten this yet, in the calculator, you type in your first number. On the TI ones that are generally blue, maybe you have a pink or a green one, there is a PRB button that we've been using. You press that. You scroll over and select the NCR option because we are doing combinations right now. You type in the R, so in this case that would be a 5, and then you press equals. If you're doing this by expansion, the reason that we can cross out numbers from the top and the bottom is that we are simplifying using multiplication. So 5 times 2 in the denominator is equal to 10. So if we have a 10 in the top and the bottom, we can cross them out. 4 times 3 I could have written as a 12. So if I have a 12 in the top and the bottom, I can cross those out. I just didn't write the step where I actually multiplied 5 times 2 and rewrote it as 10. If you just want to stick with your calculator and you know you're going to bring it and use it, that's fine. You don't have to do it by expansion. This type of problem is just a little bit different. A salad bar offers 8 choices of toppings for lettuce. And how many ways can you choose 4 or 5 toppings? What's different about this problem? We have that or in there. Okay? So it's like doing 2 problems in one. So for these, we're going to stick to the calculator. Okay, because if we do them by expansion, which you can do, I just don't want to take the time to do that right now. So I want to show you how to set up this or business. So the first case would be that we're choosing 4 toppings. How many options do we have total?
8.
8. It says we have 8 choices. 8, and we are choosing how many of them at first? 4. The other problem we would be setting up is what? 8C5. So this would give you how many options you have for 4 toppings. This would give you your options for 5 toppings. What do you think we want to do with those 2 numbers once we get them? Combine them, which in math we usually call that. How do we combine in math? Add. We're going to add them together. So those of you that can do this in your calculator, what is 8 8C4? 70 plus what is 8C5?
56.
So how many options do we have?
126.
126. Questions about number 12? We did 8C4. We're good on this one? Okay. On 13, a pizza menu allows you to select 4 toppings at no extra charge from a list of 9 possible toppings. In how many ways can you select 4 or fewer toppings? So this one is different again. If you're selecting 4 or fewer, you could select 4, or you could select 3 or 2 or 1 or 0. So now we have several different possibilities we have to account for. How many options do we have total?
9.
Careful.
9.
9. So we have 9 and we could be choosing 4 of them. We said we could, instead of choosing 4, we could just choose 3. We could choose 2, choose 1, or we could choose to have no toppings at all. That would be fewer than 4. No, what do we get when we choose 0?
1.
All right, so let's figure out what these all are, and then we are going to have to add them all up to get a total. Who calculated 9C4? 126. What about 9C3? 84. 9C2? 9C1? And 9C0? Okay, then we just have to add them all together. We get 256. So 256 possible ways. Questions about 13?
So you can have 256 possible ways to add toppings.
Yes.
To have pizza.
Yep. You have 256 options.
A lot.
It is. All right. One more. 10 candidates are running for 3 seats on the county board. In how many ways can you vote for 3 or fewer candidates? So 3 or fewer means that we could vote for 3 or 2, 1, or 0. So we've got options. How many people could we possibly vote for? How many options do we have?
3.
So yes, we can only vote for 3, but how many are we picking from?
10.
10. So we are picking from 10 options. We only get to choose 3 of them, or 2 of them, 1 of them, or none of them, in which case I don't know why you went to vote. If you're not going to choose 1, I'm not sure what you're doing, but it is a possibility. So then we would add up all those possibilities. What's 10? Choose 3? 120 plus 35 plus 45. Sorry, misheard you. Plus 10. Okay, plus 1. If we add them all up, 176 possible ways to vote. Questions about 14? Yes, your calculator will make a huge difference on these problems. It makes them go way faster. It is possible to do without, but it makes it go a lot faster.